Hi there. So we're going to be working on conics and we're going to start our unit with circles and we're going to look at the distance formula, the midpoint formula, and how to derive the equation of a circle. So let's get started. A circle you can see right here, we're going to refer to the center as HK. So if HK is at the origin, then this would just be x squared plus y squared because h and k would be 0 equals r squared. So you notice that the x and the y are both squared. This is an equation of a circle, and r stands for the radius, which takes us from the center of the circle to the edge of the circle. So let's look at deriving the distance formula first. The distance formula is derived from the Pythagorean theorem. So if we look at this triangle here, we could look at what is the length of this side here. We could call this side A. So side A is going to be, these are the x values. So if we take the difference between 4 and 0, we get 4. So the length of that side is 4. Now, if we look at the length of this side of the triangle, we would be looking at the y values. And so we notice we start at 0 and we go up to 3. And so the length of that side is going to be 3. And then if we're looking for this side right here, which we could call R, what is the distance from the origin out to this point here? Well, if we wanted the length of that right triangle, the hypotenuse, we would simply do a squared plus b squared is equal to c squared or r squared. And so 16 plus 9 is 25, which equals r squared. And so when you square root both sides, r is equal to 5. And so the length here is 5. And of course, that's a special right triangle. It's a 3, 4, 5 that you're familiar with geometry. But let's look at then how we come up with the distance formula when we are looking from the distance of here out to here. So in the second example, you're going to see that I'm deriving the distance formula, and I'm doing that by using the Pythagorean theorem again. So I used the variable d to stand for distance, and I'd be looking for the distance between this point and this point. So again, the same thing, all I did was look at the distance between these 2 points by subtracting the x values, the distance between the vertical 2 points by subtracting the y values, and then throwing it into the Pythagorean theorem. So then this would be a squared, which is x sub 2 minus x sub 1 squared, plus b squared, which is y sub 2 minus y sub 1 squared, equals, and I use d squared. And then how do you get rid of that square? You square root both sides, and then here's the distance formula. So let's look at example 1. We're going to, in example 1, find if this is an isosceles triangle. So the first thing I did is I simply graphed these coordinates. So -2, -3, I called point A, 2, 0, I called point B, and then -5 up 1, I called point C. And we're trying to figure out an isosceles triangle, remember, is 2 of the sides would be the same. So isosceles triangle, 2 of these would be the same length. Just looking at it, it doesn't really look like an isosceles triangle, but I could go ahead and find the distance from point A to C, point C to B, and point A to B. After finding the distance, I can see if any of those come out the same to determine if it's an isosceles triangle. So again, we're going to be looking for the distance between A and B, the distance between B and C, and the distance between A and C. And I'll quickly just maybe do one of these. So looking at the distance between A and B, I would take these 2 points and then just use the distance formula. So the distance is going to be equal to the square root of, and then subtract your x values. So 2 subtract -2 squared, and then I have plus, and then the distance between the y values would be 0 subtract -3 squared. And so 2 plus 2 is 4, and 4 squared is 16. So this is the square root of 16. And 0 plus 3 is 3, and 3 squared is 9. And the square root of 16 plus 9 is the square root of 25, kind of out of room here, which equals 5. So the distance from A to B is 5. So I'm going to quickly do that for B and C. And tried the distance between BC and the distance between AC on your own. I did that, and for BC, the length of that was 2 square root 5. And, ooh, that didn't work. Highlighter. And then the distance between A to C was the square root of 65. Now, because all three sides of the triangle are different, then this is not an isosceles triangle because two sides are not the same. So the answer would be no. It does not form an isosceles triangle. So now we're going to look at midpoint formula. The midpoint is the average of the x coordinates and the average of the y coordinates. So you can see here, you would add the x coordinates together and divide by 2, and then add the y coordinates together and divide by 2. So looking at this, we're supposed to find what are the coordinates of B if the midpoint is 2, 4, and the other point on that segment is -1, 9. So looking at this, we will use this midpoint formula. I could call B x sub 1, y sub 1. So I'm going to add, and then I could call A x sub 2, y sub 2. So I could add my x coordinates together. So here's x sub 1 plus -1. So subtract 1. And that's going to be divided by 2. And I know that that equals the midpoint, and the midpoint is 2. So this would equal 2. And I'm going to simplify that in a minute to solve for x sub 1. Then if I want to find y sub 1, I would add my y coordinates. So I have y1 plus 9. And again, I'm finding the midpoint. So I would divide it by 2. I'm taking the average, and that's going to equal that midpoint y coordinate, which is 4. So from here, you're just going to quickly solve. Take this 2 and multiply it to both sides. So here it cancels. And now I have x sub 1 subtract 1 equals 4. Add the 1 to the other side, and the x coordinate is equal to 5. Over here, same thing, multiply both sides by 2 to solve for y. The 2's are going to cancel on the left-hand side. Then you have y sub 1 plus 9 equals 8. Subtract the 9 over to the right-hand side, and your y coordinate is -1. So this midpoint value, or sorry, not the midpoint value, B is going to be equal to 5, -1. I'm going to derive the equation of a circle. A circle is the locus of points x, y that's equidistant from a given point. So the given point is going to be here in the center of the circle. So we're going to look for the distance from the center out to the side of the circle, which is actually called the radius. So the radius is going to equal the square root of, and then we would subtract the x value. So I have x1 subtract x2. So x subtract 0 squared plus, and then the distance between the y values would be y subtract 0 squared. And now if we square both sides, the square root and the square will cancel each other out, and we have the equation of a circle when the center is at 0, 0. So r squared is equal to x subtract 0 squared, which is x squared, plus y subtract 0 squared, which is y squared. So here's the equation of a circle when the center is at 0, 0. Deriving the equation of a circle when the center is not at 0, 0 is the same process. So now the center is at HK, and we're going to simply use the distance formula to find the length of that radius. So we have r is equal to the square root of, we'll take x and this time we'll subtract h squared. Then we'll take y and subtract k squared. And now we'll go ahead and square both sides. The square and the square root cancel. And my equation of a circle when the center is not at 0, 0 is very similar. It's r squared equals x subtract h squared plus y subtract k squared. And that's deriving the equation of a circle when the center is over here. So example 3, find the equation of a circle that has -1, -2, and 5, 3 as endpoints of one of its diameters. The center will be at the midpoint of the diameter. So this is kind of a sketch. I really just kind of eyeballed it. But if I said that this point right here is -1, -2, and this point right here is 5, 3. What I need to do is find the midpoint, or I need to find the center of the circle, because to write an equation of a circle, I need this equation here. R squared equals x minus h squared plus y minus k squared. So the first thing I want to do is figure out what h and k are. And hk is going to be the center of that diameter, or the midpoint of that diameter. So let's do that first. So you'll add your x values together. So it'd be 5 plus -1, and then cut it in half, and then 3 plus -2. Or you could just put 3 subtract 2 and cut it in half. And that's going to be my HK. So 4 divided by 2 is 2. And 3 plus -2 is 1. And 1 divided by 2 is 1/2. So now that I have found the midpoint, which is the HK, the center of the circle, I need to find this. Now I can find the distance of the diameter, and then I could cut it in half, and that would be the radius, because I'm looking for the radius. Or I could use HK and find the distance from HK to say 5, 3. I'm going to go ahead and look for the diameter. So the diameter is going to be the square root of, you'll subtract your x values. So 5 subtract -1 squared, and then make sure you start with the same point each time. So now start at 3 and subtract -2. So 3 minus -2 is 3 plus 2 squared. So the distance of this diameter is going to be the square root of 6 squared plus 5 squared. And that's the square root of 36 plus 25. And that's going to be the square root of 61. Now keep in mind, that's the diameter, but I want the radius for this problem, so I can write the equation. So the radius is half of the diameter. So the square root of 61 divided by 2. So now what we're going to do is I have HK and I have the radius. So I'm going to use this equation right here, and I'm going to write the equation of the circle. So it would be r squared, and so this would be the square root of 61 over 2 squared is equal to x subtract h, which is 2 squared, plus, oh, I forgot the parenthesis up there, y subtract k, which is 1/2 squared. And then what I would recommend is let's just simplify the radius a little bit. When you take the square root and square it, those cancel. So that's just going to be 61 over 4. So final answer, x subtract 2 squared plus y subtract 1/2 squared is equal to 61 over 4. You could use the decimal there if you wanted, but I'm good with the fraction. So example 4, the point 1, 4 is on the circle whose center is at -2, -3. Write the equation of the circle. So here's the circle. Here's a point on it at 1, 4. The center is HK. So I'll put an H and a K. And the center is here. And that is at -2, -3. Now, when we write the equation, here's the equation of a circle. I know what H is. I know what K is. Now what I need to do is find R, which is the radius. So I'm going to find R by finding the distance from the center out to that point 1, 4. So R is equal to the square root of, and I'm just going to use the distance formula. So I'll subtract the x values. 1 subtract -2 squared, and then I'll subtract the y values, making sure I start with the same point. So 4 subtract -3 squared. The negative is a plus on both of those. And then we'll just simplify that. So the radius is the square root of 3 squared plus 7 squared, which is the square root of 9 plus 49. And remember, don't take the square root. You have to add them together first. So that's the square root of 58. Now, my formula, do you notice that my formula wants an r squared? And this is what r equals. So r equals the square root of 58. So I still need to rewrite this as r squared, which would be the square root of 58 squared. So basically I'm squaring both sides. And then the square and the square root will cancel, and r squared is simply 58. So now I'm ready to write the equation. It would be x subtract h. Again, h is the -2, so plus minus minus is a plus. And then y subtract k, so y minus -3, which is plus 3 squared, equals, and r squared is 58. And that is the equation of the circle that goes through point 1, 4 and has a center at -2, -3. Example is a you try, which means you should try it, stop the video, try it, and then check it. So I'll go ahead and do the you try. So I'm supposed to find the diameter, which goes through the center of the circle from edge to edge of the circle, and the center of the circle. So I'm supposed to find those two things. So to find the center, this is going to be x subtract h squared plus y subtract k squared equals r squared. So h happens to be 9 and k is 0. So that is HK, which is the center of the circle. Now, r squared is equal to this 24. So if r squared equals 24, then when I square root both sides, I would get the radius. So the radius is the square root of 4 times the square root of 6. That's 24, which is 2 root 6. Now, it asks for the diameter, and twice the radius is the diameter. So I would need to multiply this by 2. And the radius, or not radius, diameter is what I meant to say, is 2 times the radius, which is 2 root 6. So the diameter is 4 square root 6. Thanks, that's it. Don't forget to do the reflection question and then save these in your notes for the notebook test.